In this lesson, we will define parallel lines, establish criteria for two lines to be parallel, and calculate slope and y-intercept for lines given in different representations. Let's get started and define parallel lines. Two lines L1 and L2 will be called parallel if they have exactly same slope but distinct y-intercepts. So let's get started with questions now. Here we are given four lines and we need to find out which one of the line in part A, B, C and D are parallel and which one are not parallel. So for that purpose, according to the definition, we are going to calculate slope and y-intercept for each of these parts. So for part 1, so let's start part 1. The line L1 in part 1 passes through 2 points 0, 5. So L1 passes through A. What is point A? A is 0, 5. And there is another point. The other point is B with coordinates 4, minus 3. And B, 4, minus 3. For this, we need two things. We need to find out slope and we need to find out y-intercept. For slope, if 2 points are given, that's easy enough. We can use 2-point formula of slope and calculate the slope. The starting point can be taken as x1, y1, and the second point can be labeled as x2, y2. And now if M represents, or rather call it M1, if M1 represents slope of line through A and B, through A and B, then what would be M1? M1 would be equal to y2 minus y1 over x2 minus x1. x2 minus x1. So this is going to give us the value for M, and M1 we can calculate minus 3, that is value of y2, minus 3 minus 5 over 4 minus 0. So this should give us the value for M1, which is equal to minus 8 over 4, and the answer is equal to minus 2. This is slope of line L1. So let's write down M1. And now the other thing we need to find out for this line is the y-intercept. For y-intercept, what is that we know? Where is the y-intercept? The y-intercept is a point on y-axis for which x is equal to 0. Y-intercept is a point on y-axis where x is equal to 0. And if you look carefully through these points, one of the points has x equal to 0. Point A has x equal to 0. Abscissa there is equal to 0. Therefore, point A is the y-intercept for this line. So here, point A Here A with coordinates 0, 5 is in fact y-intercept. Y-intercept. So the value of M is equal to -2, and C, some people may denote this y-intercept as B value, but that's fine, whatever letters you use to represent y-intercept. But you should remember that y-intercept is the point where line intersects y-axis, and for that point x is always equal to 0. This is equal to, C is equal to 5. So this is for M1 and C1, just to indicate that these are the slope and y-intercept for line 1. Now we will move on to the second line and we will find slope and y-intercept for line 2. For line 2, for L2, what is given? We are given equation. We are given 2x plus y. 2x plus y is equal to 5. And this is not the situation where we are given 2 points, but we are given equation, and we know that we can find slope of the line from equation by converting that equation into slope intercept form. So for converting this line, into slope intercept form, what is the first thing we do? We isolate y on left side. We isolate y, and what we do for isolating y is that every term independent of y must be transferred to the right side of the equation. And for that purpose, this is what we are going to do, is we are going to transfer 2x to the other side, and this will give us y is equal to minus 2x plus 5. Now because this is slope intercept form, and in slope intercept form we have a 3-point strategy. The first, isolate y. Number 2, make 2 observations that coefficient of x is slope of the line. Here coefficient of x, is M2, means slope of this line, and this is equal to -2. And what is y-intercept? The y-intercept for this is the constant term, that is 5 again. So C2 is equal to 5. For line 2, y-intercept is 5 and slope is equal to -2, which means that slope and y-intercept of first line and second line are same. This means that lines are in fact same, consonant line. They are not distinct lines, because for parallel lines y-intercept must be distinct. Since M1 is equal to M2, but C1 is not, it should be distinct. These both values of C1 and C should be distinct, but they are not, they are equal. But C1 is equal to C2, so L1 and L2 are same lines. So if they are the same line, there is no question of being parallel. Now let's go to line 3, and for line 3, what is the question given? The question is given here. We need to make an observation that we will find out what is slope for this line produced in the graph. For C, let's call this L3. If this is L3, third line, we know that y-intercept is equal to 1, 2, 3, 4, 5. So C is equal to, C3 is equal to 5. Means point of intersection with y-axis is A 0, 5, and slope is equal to, slope on the graph for this line, we can find out the slope by rise over run. For rise, we can mark 2 points. Always mark only those points which pass through the corner of the square, because that's how you can read the values in whole numbers. So if we mark this as point A and mark this as point B, then we can either run first 1 and then rise for 2 values down. So slope, which will be equal to rise over run. Here rise is -2 because we are coming down, and then run is 1 unit to the right, so that should be positive. Therefore M3 is equal to -2. And again, this line has the same slope and the same y-intercept. So this was for part 3, and now for part 4 we will find out what are the slope and y-intercept for this line. For line given in part 4, for line given in part D, what is angle with x-axis? Angle of line with positive x-axis is equal to 45 degree. If this angle is equal to 45 degree, we can call this as angle alpha. This is equal to 45 degree. Whatever angle line makes with positive x-axis, if we take tan of that angle, that is slope. So M4 will be equal to tan of alpha. That will be slope of the line given in part 4. So this is equal to tan of 45 degree, and we know from the table of values that tan of 45 degree is equal to 1. Here M4 is equal to 1. And what is given for y-intercept? For y-intercept we are given that this is at point 0, -2. Y-intercept is given. Y-intercept is given that C4 is equal to -2 because the line intersects y-axis at point 0, -2. So from data calculated in A part, B part, C part, we know that L1, L2, L3 are same lines. Basically, those are just different representation of the same line because their slopes are same, their y-intercepts are same. And L4 is not parallel to any of the lines in L1, to any of the lines that's in part A, B, or C.